Hello and welcome back. So now that we know what the atmosphere is made of, and we know the various layers of the atmosphere, the next thing that we want to talk about is how does the atmosphere generate weather? And so in this segment, we want to talk about clouds. And so how do you go about making a cloud? So you begin with a warm, moist parcel of air. So if you got the ground is down here, what we're going to have is a cloud. Well, it's not really a cloud yet, but you got this parcel of air, and it's going to be moist, so it's going to have water in it. And then it's also going to be warm because the sun is going to be shining down, and it's going to warm up the ground, and then that hot air is going to warm up this moist parcel here. Okay, then it's going to start to rise up into the air. So the next question is, well, why does this thing want to rise up into the air? Okay, if you remember when we talked about what causes plate tectonics, we said it was convection. And convection was when in the mantle you had hot material, and then it would come up to the surface, it would cool off, and then it would go back down. Well, why would it go up in the first place if it's hot? Well, if it's hot, then that means that the molecules in there are moving faster, so that they are exerting a pressure pushing outwards on this thing. So that means the density of this thing is going to go down. This is going to be less dense than the surrounding material because this material is more spread out because of the heat. And you should know that less dense things float on top of more dense things. So if you mix oil and water, the oil goes to the top because it's less dense. So similarly, this parcel of air is going to start to go up into the sky until it reaches the altitude at which its temperature is the same as this temperature out here. So that's how high a cloud is going to rise. Okay, now let's assume it rises so high that the water in here cools down to the point at which it starts turning into a liquid. So when that happens, and then you've got liquid water in there, that's when you can see the cloud. And so that's how we make a cloud. Okay, let's go on a little bit here and talk about what pressure is. So pressure is going to be given by the letter P, and it's the technical way of calculating pressure is it's going to be the force that is acting on something divided by the area that is acting on something. So let's take a look, for example, at a pen. So a pen has a pointy end, and then a pen has a rounded end. So I'd like for you to kind of do a little experiment here. So if you take your finger and start with the rubber end, or the not so pointy end of the pen or the pencil, and push your finger back maybe a half an inch or 1 centimeter with that thing. See what it feels like on your finger. Okay, now flip it around so that you've got the pointy end pushing against your finger, and push it back the same distance, so 1 centimeter, half an inch. And what does it feel like? Well, this time it kind of hurts when you do that. So what's the difference? They both have the same force because your finger is going back the same distance. But what is different is the area that is the force is being concentrated onto. So if you're using the rounded end, you notice that the area is much larger than the pointy end. And so you should also know that when you've got a fraction and you divide by a small number, what comes out? A big number. On the other hand, if you divide by a big number, what comes out? You get a small number. So what you're really doing when you're using the pointy end is you're applying more pressure to your finger. And that's what causes the pain. So it's not necessarily the force. Because, for example, have you ever seen, I guess you call it a magic trick, but it's the bed of nails type thing? And they're laying down on a bed of nails, and yet, so you take a look at this, for example. It's a bed, a piece of wood, and it has a whole bunch of nails that are driven into it. And then the person lies down on top of this, like that, and then another person can even stand on top of him, and he's okay. So why is it then that he is okay? So each of those individual nails has a lot of pressure associated with it, and so any one of those nails could skewer that guy. But if you spread the nails out over a large area, well, now all of a sudden the A gets big in the bottom part of that formula, and the overall pressure, the thing that's going to want to push those nails into the person, has decreased. So it's okay. So it's not really a magic trick, it's just applied physics. So that's what pressure is. It's concentrated force. It's the official metric unit would be the Newton per meter squared. The Newton would be the force. The meter squared would be the area. So Newton per meter squared. Now what we're really interested in here, though, is what do we mean by atmospheric pressure? The pressure that you're feeling right now on your body is being caused by the weight of all the air that's on top of you. And that air goes all the way up to 10,000 kilometers, or 6,200 miles of air are on top of us. So that, now most of that air is concentrated here at the surface of the Earth. Like 90% of that air is within like 10 kilometers of the Earth's surface. But the atmosphere of the Earth actually extends much, much further out into outer space. So if you were to take the weight of all the air that's pushing down on top of us on 1 square meter, so 1 meter by 1 meter, then that would be the atmospheric pressure in newtons per meter squared. So just to give you an idea, so here are some typical pressures. Now a newton per meter squared is called a Pascal and is abbreviated with a PA. So 1 PA is going to be equal to a newton per, can't see that, so let's try it over here. Pascal equals newton per meter squared. So it's the same thing. So that's the official metric unit for pressure, and there are some pressures. So when we say that you're feeling a pressure of 1 atmosphere, then that means you're feeling the weight of the entire atmosphere of the Earth pushing down on you on a 1 meter by 1 meter area. Well, the last thing I want to mention here is what's the difference between a high pressure system and a low pressure system. So a high pressure system means that the pressure is pushing down. A low pressure system means that the air is rising. So this has a higher pressure, it's pushing down on the atmosphere. The lower pressure means that the air is less, there's less pressure. So which one would allow clouds to form? So we just got through saying that a cloud rises into the air until it cools off and then becomes a cloud and then turns into a liquid. So a low pressure system is going to allow the material to go up and turn into a cloud. On the other hand, a high pressure system pushes down and it's going to push the clouds out of the way. Another thing that you notice is that the wind systems will rotate around a high pressure system and a low pressure system. So that's not so important to us. And then also you'll notice that winds tend to blow from high pressure systems to low pressure systems. Okay, in our next segment, we're going to talk about the Coriolis force. So I'll see you in just a moment.